Hi, everyone. All right, so let's get started. I think it's going to be a long-ish video, so let's go straight to the matter. So the reason it's going to be potentially a longer video is that we have a lot on our plate for this coming week. And part of it is because, it is the summer session, so we only have a few weeks together to go over a lot of material. However, I will say I've done this for many summers at this point, and it's always worked out really well. So we just need to be, ready for what's coming. So here we are on our homepage. I'm going to go to modules, and then from here we're going to review when you need to complete by tomorrow, and then we're going to jump to the new material. So last weekend, so right before everything started, we shared the Canvas shell, and what we were looking at this week were the course introduction module and the course overview module, where in the course introduction, you see you had course introduction survey and course introduction video to complete. Those are due tomorrow. And I will also explain in a second why it's important that you complete those, aside from, the fact that it is for credit. The other thing that we looked at is Unit 1, Mechanics 1, and starting with Chapter 0. So the first homework assignment, which is here, also due tomorrow. Also, part of your final grade. This is your first homework assignment. The only assignment that's not for credit is the pre-chapter check. So again, that's something that you can do if you have the time, if you want to get a sense of, what the chapter is going to be about, to maybe assess the amount of time that is going to be needed for you to complete the assignments. So the reason I mentioned that it's really important that you complete these first assignments is that because this is a fully online course, it is asynchronous. This is how I'm checking that you are still part of this class and that you're active. And June 16th is Census Day, when I will have to essentially check that everyone is actually active. And so if you have not completed anything by then, you will have to be dropped from the course. So again, very important. So make sure that you complete these assignments. Again, because you want to do so by the deadline to receive credit, but also to keep your spot in the class. Also, I will add that I think the original plan for conceptual physics for summer at Skyline, so I teach the two sections. We were supposed to have 50 students, and the wait lists filled up almost right away. So both of the wait lists. So we then increased the class size, and then I added students on the new wait list after that. So we've almost double capacity. So what that means is, well, first, it's great because it's good that we have a lot of you participating in the class. And that makes the discussions richer and whatnot. The only thing is 50 versus 90 plus means that, as you can imagine, grading takes a lot longer. So I'm going to try to be really diligent, but I just want to let you know that again, that was not the original plan, but I really wanted to make sure we could accommodate all of you interested in taking this class this summer. So just a quick note on that. All right, so let's keep going because now the focus is going to be on what's coming up for this week. So our second week of the summer, again, 1 week is actually a really big chunk of time in our summer courses. So what you're going to see is that this week we're going to cover 2 chapters. But as you can see, that takes us already to the end of Unit 1. And the way the course is organized is that you will get an exam at the end of each of the units, um, or almost, not the last one. You can go back to the video that shows you the schedule for more information. But I just want to let you know that it is coming up. We have time and we have many tools to get ready. So I'm going to talk about this in this video as well. So you can start, thinking about that as it will be coming up the following week. Um, and I also wanted to show you that Unit 2 has been published. So all of the assignments from Unit 2, Mechanics 2, are open except for the exam. So you can also take a look and get started if you are, working through all of those assignments. You can see this one has more chapters, but again, typically a unit is going to be covered in a couple of weeks and then end with an exam. So shortly, I will also publish Unit 3 and 4. Again, I don't want to overwhelm you, but at least I want to make sure that I give you plenty of time. So, I would actually recommend that you start early if possible. And don't wait, like for example, we're looking at this, you have all of this due July 6th, don't start July 5th. You have 3 chapters, for example, there. Okay, so we just want to make sure we plan ahead again because in the summer course, things move very, very fast. So, with that said, we're not on Unit 2 yet, so we're going to take a look at our upcoming chapters for Unit 1. So I showed you how you can navigate the course last week. So now starting with chapter 1, what I would do is click here on chapter 1. You'll get an overview of the chapter. So we start with an overview using the textbook. We take a look at the learning outcomes. So you can see here a number of definitions that we're going to go over. Position, displacement, distance, speed, velocity, acceleration. Sometimes, it can be tricky because it sounds similar. So it's like, what is the difference between all of these? How do they relate? Things like that. Some of these are scalar quantities versus vector quantities. So that's another thing that we're going to talk about in this chapter. And that has to do with something that we call kinematics. And in this chapter, we're going to really talk about motion and how to describe motion. So all of these are very useful to describe motion. We're going to talk about equations of motion and in specific examples where we can simplify things a little bit. So here, for example, you can see we're talking about motion, constant acceleration in one dimension, for example. And then when we move to 2 dimensions, then we'll talk about projectile motion. And we'll take a look at some examples actually in this short video because the activity for this week is a projectile motion simulator. You have a pre-chapter check for this one, just like all the other ones, a link to the chapter in the textbook, Then you have some short videos. So these are really to introduce the topic. They're nicely illustrated. You can skip over those if you are not interested, but it's also a different way to present the topic. So these are from different resources if you are interested. So they're here for you to take a look. And otherwise, you can see that we're going to have a homework problem set and an activity again based on projectile motion. This one is not a discussion, it is a quiz, but we'll see that it uses that simulation that I mentioned. So here we have the pre-chapter check. Again, if you want, you can skip over this one because it's not for credit, but it's very short. It doesn't matter if you get all the answers wrong. It's really for you to do a self-assessment of where you're at with this topic, again, because it may be something that you've studied before. So to get an idea of how much time you want to spend on this. Okay, so after this, we go to the lecture videos. So there are several tabs here. One is kinematic variables. So that's the ones that I just mentioned, like position, velocity, acceleration, but also like distance and displacement, etc. Then we talk about motion with constant acceleration. So you'll know more about acceleration after watching the first video. And in one direction, a lot of time with the free. We talk about free fall when constant acceleration is due to gravity, and then projectile motion when we go to two dimension, and we'll talk about uniform circular motion as well. There are some videos, I think the numbers may not match, but because they sometimes are randomized, but also at one point we switched the numbering of the chapter, so don't worry about that. But some of the homework problems are worked out in some of these videos. So if you're stuck on the problem, you can also come here to check if you can get some help. All right, so then we can go to the corresponding activity. And you can see that this one is going to be a quiz, but it tells you, all right, so go to this simulation. We're going to take a look together. Then it tells you select the lab tab and select an object to throw at different angles. And so essentially practice, and then the quiz will actually just ask you some questions that you can solve directly by looking at the simulation. So you can see, again, you're welcome to take a look at all of these different tabs. We're going to look at the lab one. I just want to show you how to navigate this. And so you can see that we have the Canon here, and I can change the angle. So, and you can see that we can read the angle right here. There is a target that can be moved over here. I can change the initial speed of my projectile. So we're going to pick a projectile. Right now it's a cannonball with a mass of 17.60 kilograms, a diameter of 0.18 meters. We are on Earth with a gravity acceleration due to gravity of 9.81 meters per second squared. In Discord, sometimes we round this up to 10 just to make calculations easier. But you can change that to go to the moon or something else. You can see that we can add air resistance if we want. We can change our projectile. So I could throw a piano. I could change the angle. I could change the initial speed. So again, I could launch. So we can Trying to launch, with zero speed, but it's not going to do much. We can try and see what happened. Yeah, so you can see it just crashes here. And then we can change the speed and see what happens. It goes pretty far. And so you can see that I can make my piano much heavier. Um, all right, we can see if that makes a difference. We can change the diameter. Again, you can change all of these parameters. You also have tools. So this one is pretty cool because it will show you, like, you can pick a point in the motion and it will tell you, okay, this is how much time from when I launched. So it was 0.9 seconds. The range is the horizontal distance traveled. So it's this distance from here to here. The height is the height from the ground where it was launched. Um, and I also have this that can help me measure. So I can actually check, can I trust the measurements that were given? So if I start here, I go to the initial point and I drag this out to about here. You can see um, it's actually not quite right. I think I'm not. Oh, anyway, yeah, I think you get the idea. Okay, so here. It's not as precise as they are, but you can see the range here. It's fairly close. I measured to like 8.91 meters. Probably if I was more careful, it would give me the 8.81 that we see here. All right, so I would encourage you to explore. I would also use this as maybe solve some of the problems in your homework, or you can see this is actually really a good illustration in terms of like the symmetry of the motion, how you can calculate, various things. Also, if you want to, I mentioned vectors, a number of, those variables, so velocity, that will, um, um, just go a little bit ahead of what, we haven't seen the lecture, but velocity is a vector quantity and like speed. But so for now, I'm going to launch my cannonball. All right. But for this tab, you can add things like the vector for the velocity. You can add the acceleration vector in yellow. Force we haven't talked about, but we can always come back to that later on. So you can see that it shows you what those look like. And you can see actually something really strange was happening, that the acceleration is actually not horizontal, and it's because we have air resistance. If I remove air resistance, you'll see that, yes, it is vertical. And we have something very symmetrical. Anyway, you'll get to learn more about that. And I should probably move on because we have another chapter to go to. But using the simulation, you will be able to answer the questions that are in the quiz for this one. Then it takes you to the homework that you can also, just complete from here. And we have one more chapter to cover this week. In this chapter, is very much related to the previous one. This one is dynamics. With kinematics, we learn about how to describe the motion. With dynamics, we try to understand where that motion came from. So how did the object start moving? Why is it moving this way? So we can describe it already from chapter 1. Chapter 2 tells us, what is causing this motion. And this is the chapter where we get introduced to forces, and we're going to look at a number of examples of forces. You can see we're going to define what a force is, talk about the normal force, spring force, friction, and another really important part of this chapter, and something that we use quite a lot throughout this course would be Newton's laws of motion, and there are three of them. So this is something that is going to be most of the chapter here, and again, very important. The structure of for this chapter is exactly the same as before. What changes, obviously, is the content. As I mentioned last week, I recommend watching these videos. If it's too much, you can skip over them. I would recommend checking out the textbook. Um, but if you'd rather like pick between reading the textbook and watching the videos, that's fine because it covers the same material. So again, depending on how you learn, what is your learning style, what works best for you, also given time constraints, you can decide to watch the videos, you can decide to rely on the textbook. So this is up to you. You don't have to do everything. So I just like to give you resources, but you get to pick which ones you use. Um, okay, so you have again the pre-chapter check. And then the lecture content. So those are my videos. You have the handout for the videos. You can see we're going to do a little bit of history and talk about forces, the laws of motion, first, second, third. So this is the first tab, and then we take a look at applications, and that's when we start talking about different types of forces. So we'll look at examples and additional resources. So things like the simulation that I just showed you, and other things that can help you, understand some of the topics a little bit better. For the activity this week, so the second activity of the week, we have this thing called Whack Stack activity and discussion. So for this one, you have a choice of two little experiments that you can do. And so one is Whack a Stack here. So essentially you can see what this is. The idea is to find things around your home. It doesn't have to be as big as this, but essentially finding something that is going to act like, the stick here, and something like a number of objects that you can stack together. And we're going to be testing out Newton's first law. And so again, by now, I think I've seen hundreds of these, but it's really fun to see how creative everybody gets. So you can create different stacks. Some are going to work better than others. It actually does not matter if it works as it's supposed to or not, because we're really testing our hypothesis and see if it works. This is pretty clean. It works very well. Sometimes the object you stack may, sort of stick together more. Like there may be more friction between them depending on the material. So it may not work as well. Sometimes it may be too heavy. So again, that's going to increase the like friction and is going to just make it harder to complete the experiment. I've seen people like just have fun and create like a very large stack of objects. Or we've had, little things like coins and things like that. So you can find random things around your home and and figure out what is going to be the stack of objects and what is going to be, like the what you're going to be whacking that stack with. So that's one of the options. If you're going to post about that, you want to describe what is your whacker, what is your stack, did it work? If not, what do you think happened? So was it because of friction? And take a picture of your setup or a video of your experiment and post that. Another option, if you prefer, is the egg drop experiment. Some of you may be familiar with it. And so same idea again. You know, that can get messier depending on how you do this. So this is the alternative. There's more videos that you can watch. I didn't realize there were so many eggs. But that's the other one you can complete. And so same thing as the other experiment. If you go with the egg drop, you describe your setup and again, take a picture or video. It's always fun to see the videos of the egg drop experiment because somehow it always feels like, oh, is it going to work? Usually it works, and hopefully for you, I hope it works. But I really hope you have fun with these. It's really sometimes like, we see the equations, we see the problems in the textbook, but I think it's really important to actually apply in real life some of the things that you learn because that's when you can sort of relate. You will start seeing these laws everywhere and see their applications. So, we start with these examples, and you may start noticing other examples, around. Um, After that, there is the homework set two. Obviously, you can do one after the other. It doesn't matter for that. And then I'm going to spend a little bit more time. I told you this was going to be a long video. There's a unit one wrap up. So this is again to talk about some applications that are not necessarily like straightforward things that you would see in the textbook of what you've learned. To kind of expand on why we're doing what we do and why we're learning this material. Um, and so for so this is not happening this week, but it will happen the following week. So I want to make sure that you're prepared. But as we're wrapping up the first unit, that means that we will have the first exam. Um, so the first exam will be open Monday through Friday, the week of June 23rd. So again, there's time, but it's, a week goes by and that's it. So uh, once you start this test, it will be open for 3 hours, which is way more time than you need. But this is to make sure that if there's any technical issues or anything like that, you still have time to complete the tests. It's also to reduce sort of the stress due to limited time and things. And 3 hours, that's way more time than you need to answer three multiple choice questions on those three chapters. You should easily be able to finish in an hour. So there you go. Um, and so these are the topics that are included in the three chapters. So they're going to be the focus. Um, but I'm going to show you. So I think it comes up if I keep going. There is a practice test. The beauty of this is that, so you can take this, you can see 100 times. I don't think anyone's taken this 100 times. You don't need to try to test that. Um, so this is not for credit. So it also doesn't matter if you get all the answers wrong. However, it's essentially, as you can see, built the same way as your actual exam. So if you do it a couple times, it gives you a really good idea of what the actual test is going to be like. So I would take it at least one time before you take the test. Um, the actual test is not open yet. It will open on the 23rd. This will be also open, until the actual exam is due. But I would highly recommend that, you try to take this test before you attempt the actual one. That way, it really gives you a good idea on how you're going to do. It gives you a good sense of the types of questions that you can expect. You can even start now, even if you've not completed all the chapters, to get an idea of what it may look like. And again, you can do it as many times as you want. Again, I don't think you're going to hit the 100 time limit, but if you do, let me know. But I would not recommend trying this 100 times. I think that would it's not the point, but really the point is to show you that you can really um, you know, uh, try it as many times as you want. So what I would do, I would highly recommend is that you try, um, after you complete the Unit 1 chapters, try kind of early to take it once to see if there are areas for which you are not ready. Okay, so that way, um, if you're not ready, you can go back to the chapters and maybe try to take the practice test again before you attempt the actual test. The other thing is that for the actual test, you will have 2 attempts. So that's why it's good to start early, because if you want to take advantage of the second attempt, it may be a good idea, let's say, to try the practice test on Monday, see how you do. If you're happy with how you did, then take your first attempt at the actual test. Then if you're happy with the results, then that can be that. Or, if you feel like, oh, I should study a little bit more, give it a couple more days and then take the second attempt. I will keep the highest score out of the two. Okay, so it doesn't cost you anything to try a second time unless if you got 100%, then that's that. But yeah, you can take it a second time. All right. I will put that all in writing in the announcement that comes with this video. I know it's getting long, so I will stop now, but we had a lot to cover. Future videos hopefully will be shorter. But if you have any questions, please don't hesitate to reach out. And we'll talk more about the exam next week as it gets closer. But I just wanted to put that on your radar so you can start thinking about it, and you can also maybe start taking a look at the practice tests. All right. All right. Have a great weekend. And again, please reach out if you need anything. Thank you so much. Bye.